Today we're going to be talking about how to read a solubility curve. And what a solubility curve shows you is how much of a substance you can get to dissolve in water at a certain temperature. So the first thing we need to take a look at is how temperature affects solubility. So how temperature will affect how much you can get to dissolve in water. And common sense, and maybe not common sense, but things that you're familiar with, if you think about it, this first statement will probably make sense. So if you heat up some water, you can actually get more solid to dissolve in it. So increasing the temperature of water will increase the solubility for solids. So if you ever want to get more sugar to dissolve, or for example, if you're making coffee, you always want to use hot water because you can get more to dissolve in the liquid at that temperature. One thing people probably don't know is that for gases, it's the opposite. If you decrease the temperature of the water, or you make it colder, you actually can get more gas to dissolve. So by increasing the temperature of water, you can get more solids to dissolve, but decreasing the temperature of water will get more gas to dissolve. And that's why if you guys fish, you should always do that, earlier morning or later afternoon when the sun isn't out beating on the water, because the water's cooler and more oxygen will be dissolved in that cooler water, and therefore the fish tend to be more active. So what a solubility curve does is it kind of explains these things and shows these things and how temperature will affect how much of something you can get to dissolve. So if we take a look at a solubility curve, this is what they look like. And I'm going to zoom in a little bit here. So essentially what it does is on the left side of the paper, it'll tell you how many grams of solute are dissolved per 100 grams of water. I'm trying to get this to show up a little bit better. It's not working. There we go. Sorry about this. I've never had this happen before. Usually it shows up. Okay. So let's do this. That's better. So what you end up having is a solubility curve where on the side of your curve, it'll tell you what's being dissolved. So this would be the grams of solute, or the grams of thing being dissolved in 100 grams of water. So all of this curve takes place in 100 grams of water. So if you have a 100 gram water sample, this is how many grams you will get to dissolve. And then on the bottom, it tells you the temperature. Okay? So for example, if I wanted to see how much KClO3 I can dissolve at 50 degrees, I'd find the KClO3 line, which is right here, and I would look at 50 degrees, and I would run it up until I hit the KClO3 line, and it looks like it's about 21 grams can be dissolved at 50 degrees. Okay? Notice at 60 degrees, though, you can get about 27 or 28 grams. So as temperature is going up down here, the amount that you can get to dissolve also goes up. So this must be a solid, right? Another example would be NH3. If we look at that line, if we increase temperature, so temperature is going up from left to right, what's happening to the line here? It's actually decreasing, right? So this would be an example of a gas. The higher the temperature, the less you can dissolve. Okay? So what we're going to do today is we're going to take this information and we are going to answer a couple of questions about that. So for example, if I asked you this first question, I have to zoom back out again. And 1 second. Okay. So if I asked you how much KNO3 can be dissolved in 100 grams of water at 50 degrees Celsius, we can use that solubility curve to answer this question. So here's the key for the first part. If your question takes place in 100 grams of water, then you know you can just look at that chart and answer the question. Okay? So we simply have to look up the temperature and the chemical, and that will answer our question for us because it's already taking place in this amount of water. So if I go back to my curve, I'm going to look up KNO3 at 50 degrees. So KNO3 here's my 50-degree point, okay? And I need to go up until I see the KNO3 line, okay? And at that temperature, I can fit about 80 or 81 grams, okay? And if it's in between, you're always going to kind of guess. And this one's a little higher than 80, so I'm going to say 81 grams. So the answer to that question would be 81 grams. That's it, okay? Now I could also ask you a question like this. At what temperature can you dissolve 122 grams of NaNO3 in 100 grams of water? Okay, well, it's taking place in 100 grams of water again, so that's pretty cool. That means we can just look at our chart and answer this question. So this one, I'm being asked for temperature, right? So I want to know what temperature I can dissolve 122 grams of NaNO3. So here are my two things that I'm going to use to answer this question. So I need to go back to my solubility curve, and I need to look up 122 grams of NaNO3. So I'm going to pull this back over, okay, and zoom in a little bit. So if I look at 122 grams, right, and I'm going to go over to the NaNO3 line, and it hits it right about here. Okay, and so that temperature, if I go all the way down to the bottom, is 60 degrees. Okay, so at 60 degrees, I can fit 122 grams. So your answer for that one would be 60 degrees. And that is how you would read a solubility curve.